Hey guys, this is CHEMPLIFIED, and in this video we will discuss the topic aldehydes and ketones, and we will start with methods of preparation of aldehydes and ketones. We know that aldehyde and ketone act as functional group in various organic compounds, but what is the method of preparation of aldehyde and ketones? We will discuss that. So our first method is oxidation of alcohols. I repeat, oxidation of alcohols. Now, how they are prepared? Aldehydes and ketones can be prepared by controlled, remember this term, controlled oxidation of primary and secondary alcohols using an acidified solution of potassium dichromate, that is K2Cr2O7 or potassium permanganate. All right. So we do the oxidation of alcohols which is controlled. What is the meaning of control? We will discuss it in the reaction. We do controlled oxidation of alcohols to produce aldehydes and ketones. Right. Let's take a look at the reaction. Now, for primary alcohols, this is 1 degree. This is 1 degree alcohol, right? This is also primary alcohol, or you can write it as ethyl alcohol, right? Now, what we are doing is oxidation. What we are doing is oxidation of primary alcohol. Now, what will happen is during oxidation, these two hydrogens will react with the oxygen provided by K2Cr2O7 to form water, right? So what is the main product that we will receive when we react a primary alcohol, when we do the oxidation of primary alcohol using K2Cr2O7 or KMnO4? We will get water molecule as one of the product. What is the other product that we are going to get is this will be your aldehyde, right? This will be your aldehyde because one hydrogen is also at this place. Now, how ethyl alcohol will react? It will give you CH3 C double bond O H plus H2. What is this? This is your acetaldehyde. That's how the formation of aldehyde took place by using primary alcohols. Now, what will happen if you use secondary alcohol in place of primary alcohol? So, for the preparation of ketones, oxidation of secondary alcohol is done. This is your secondary alcohol. When you oxidize it, you will get RC double bond O. This is your ketone. And in this reaction also, these two hydrogens will take up oxygen and form water molecule, right? Understood? I hope you understood. Now this is your 2-propanol. This is your 2-propanol. When you oxidize this, you will get your first ketone, that is acetone, right? So that's how you prepare aldehyde and ketone using K2Cr2O7 or oxidizing agent. You can use other substances for the oxidation like KMnO4. We have already written that, right? You can also use H2Cr2O7. This is just same as K2Cr2O7. This is chromic acid, right? You can also use Na2Cr2O7, sodium dichromate, right? So these are the substances. You can also use PCC. What is PCC? Pyridine chlorochromate, right? These are the substances, these are the oxidizing agents that you can use for the production of aldehydes and ketones using primary alcohols. The reaction will be same. You will get a water molecule and a ketone and an aldehyde, right? So this was the first method of preparation. Let's move to the next. This video could be longer, so I'll be reading out fast. So just catch up with me. Catalytic hydrogenation of alcohol. Wait a second. Sorry, the second method is catalytic dehydrogenation of alcohols. Now, what is the meaning of dehydrogenation? It simply means removal of H2 molecule from the given reactant. Now we have 1 degree alcohol. So aldehydes may be prepared. Aldehydes may be prepared by passing the vapors of primary alcohols over copper catalyst heated at about 300 degrees. Now when you pass vapors of primary alcohols over copper surface which is heated at about 300 degrees Celsius, what happens is the H2 molecule from 1 degree alcohol is taken out and you will get an aldehyde. There is one more hydrogen present at this place, right? Now how the bond formation took place is like this, and this will take up this hydrogen. All right. So this was your catalytic dehydrogenation of alcohols for aldehyde. Similarly, in the same way, just similarly, the formation of ketones take place as just the only difference is you will have 2 degree alcohol. You have to take a secondary alcohol for the formation of ketone. Now again, these two hydrogens will make H2 and you will get a ketone. That's how you go for the formation of ketone using primary alcohols by dehydrogenation of that primary alcohol. All right, let's move ahead. Now the third one is oxidation of alkenes. Now this is a different concept. Aldehydes and ketones can be obtained by ozonolysis. It simply means you are going to use O3. Ozonolysis of alkenes. This involves treatment of alkenes with ozone, that is our O3, to give ozonides. The ozonides are not isolated because they are explosive in nature in dry state. They decompose with ZNO and H2O to form aldehyde and ketone. Now what this statement is saying is that you have to use O3 and after that you have to also use ZNO and H2O. Now why they are doing it? Because ozonolysis will produce ozonides which are explosive in nature. So we cannot keep them as it is. So we have to decompose them further using ZNO and H2O to produce our required product, that is aldehyde and ketones. So let's see how the reaction is going to take place. For these kind of reactions, always remember whenever you have an alkene and an O3 in a reaction, it simply means that bond breaking will take place. This double bond will break. This double bond will break and the carbon will combine with one oxygen atom. And the product will look like this. Sorry. This is your first aldehyde. Alright. Now this is your second aldehyde. Look how the product is going to form. This is your acetaldehyde. And this is your propanol. Why we are receiving two different products? Because our starting product is 2-pentene and we are going to get uneven products. This is one of the limitation of oxidation of alkenes. If you use an unsymmetric molecule in the reactant, then you will get two different kinds of product which are difficult to synthesize because of small difference in temperature or other physical properties. Now, how to produce aldehyde and ketone using this reaction? You have to use symmetric molecules in the reactants, right? Like this. This is a symmetric molecule. When the bond breaking take place, you will get same type of product. All right. So this is the limitation for oxidation of alkenes. We have also now read that in statement, ozonolysis of alkene is not a good preparative method for aldehydes and ketones. This is because a mixture of carbonyl compound is often produced. A mixture is produced. However, if the starting alkene is symmetrical, only one carbonyl compound will be obtained. For example, this is your 2-butene. What happens is the bond breaking take place and you will get only your acetaldehyde, right? You will get only acetaldehyde in the product. You can write 2 in place, 2 in this place, right? So this is your final product. So you have to use symmetric alkenes for this particular process. You can make unsymmetric alkenes, but you have to synthesize them later on. Now the next is hydration of alkynes. In this method of preparation, you have to remember two different things. First one is hydration of acetylene yields acetaldehyde. In this case, we will not talk about ketones. Whenever you are using acetylene as the starting element or the molecule, you will only get acetaldehyde in the product. What is the meaning of hydration? Hydration means addition of water. Hydration means addition of water to the starting molecule. Now water adds to acetylene in presence of mercuric sulfate and sulfuric acid to form an unstable enol intermediate. This intermediate rearranged to give acetaldehyde. Right? So now let's take a look at the reaction, how the reaction is going to proceed. Now the first step is formation of unstable enol intermediate. This is your unstable enol intermediate. Now after some rearrangement, you will get the final product. Wait a second. Sorry, we only have acetylene. Wait a second, I will change it. Now, what will happen is formation of intermediate. Enol intermediate. This is your enol intermediate when acetylene is reacting, right? Now after some rearrangement, you will get the final product acetaldehyde, and it will be as this is your acetaldehyde formation, right? So the hydrogen changes its position to this carbon and you will get stable acetaldehyde. So this is the hydration of alkynes in case of acetylene. I repeat, in case of acetylene, you will get an aldehyde, right? Now why I am repeating this, let's take a look in the next. Now hydration, remember what is written in this statement: hydration of alkynes other than acetylene. Hydration of alkynes other than acetylene gives ketones. Only acetylene will give aldehyde. All other alkynes will give ketones. Water adds according to Markovnikov rule to give unstable enol intermediate. I will give the link in the description for Markovnikov rule. You can watch the video for Markovnikov rule, how the rule works. This intermediate rearranged to form ketones. Now let's take a look how the reaction is going to proceed. for the formation of ketones. Now first step is you will get an unstable enol intermediate, which is like this, right? Now after some rearrangement, you will get the final product as ketone. All right, so this is your final product. This is your ketone. Also you can call it as acetone, right? So this was your hydration of alkynes other than acetylene. So remember, for this particular reaction, remember, if you have acetylene, you will get aldehyde. If you have any other alkyne other than acetylene, you will get ketone. All right. Now this one is propyne. Sorry. Other than acetylene will give you ketone, right? For Markovnikov rule, I will give the link in the description. You can check out that video. All right. Now next, hydrolysis of gem dihalides. Now before we go for the hydrolysis of gem dihalides, what is the meaning of gem dihalides? Gem dihalides simply means halogens attached to same carbon atom. All right. We call that gem dihalides. A gem, we have also written it in the statement. A gem dihalide is a compound that has two halogen atoms attached to the same carbon. Aldehydes are prepared by alkaline hydrolysis of these gem dihalides, in which two halogen atoms are attached to the terminal carbon. Remember, the halogen atoms are attached to the terminal carbon. All right. Now when you do the hydrolysis, what you will get is, first you will get an unstable intermediate that will be like this, and this is unstable. Now what will happen is dehydration. The H2O molecule will be removed and you will get the final product as, let's take out the H2O molecule. Now this will be easy to understand. Oxygen atom will make a double bond, and this is your final product, that is acetaldehyde. Now for this particular hydrolysis of gem dihalides, remember that for the formation of aldehyde, the two halogen atoms should be attached at the terminal carbon. Right? Now what will happen if these two halogen atoms are attached at the carbon which is in the middle? You will get ketones. Ketones are prepared by alkaline hydrolysis of those gem dihalides in which two halogen atoms are attached to a non-terminal carbon atom. Now the process is same. Let's see what happens is, you will get an unstable intermediate, right? You will get an unstable intermediate. After that, H2O molecule will be removed. And you will get the final product as, this is your acetone, right? This is your acetone. So this was the formation of ketones using gem dihalides, right? So just remember these two things. In case of gem dihalides, if the halogen atoms are attached at the terminal carbon, you will get aldehyde, and if the halogens are attached at a non-terminal carbon, you will get ketone. Now this will be our last method of preparation for aldehydes and ketones. There are other methods also, out of which one is Wacker process. We will discuss that in the separate video. These are the most general methods that I have given you in this video for the preparation of aldehydes and ketones. Now, reduction of acid chloride. Now in this case, what we are going to produce is only aldehydes. Aldehydes can be prepared by the hydrogenation of acid chloride in the presence of palladium supported over barium sulfate. Now whenever you see palladium or platinum with hydrogen, it simply means reduction is going to take place. It simply means reduction is going to take place. Now what will you get is the final product that you are going to get is your aldehyde, right? And HCl will be removed. We know how HCl is going to get removed. One of the hydrogen will take up, make bond for, make compound, sorry, one of the hydrogen will take up chlorine and get out of the molecule. Now why they have written this poisoned in this place? Now why they have written poisoned? Because palladium in presence of H2 is a strong reducing agent. It can reduce the aldehyde further. It can reduce the aldehyde further and can convert it. I repeat, it can reduce the aldehyde further and can convert it to alcohols. So we don't want that to happen. We only want aldehyde as product. So you have to poison this catalyst, or to deactivate it partially, so that you will only get the desirable product, that is your aldehyde. Now this is your another acid chloride. Name you can write it as acetyl chloride. The product that you are going to get is your acetaldehyde and HCl, right? You have to poison this catalyst. You have to poison the catalyst PD BaSO4, because you want to get the desirable product, that is acetaldehyde. Why? Because this is a strong reducing agent and can reduce aldehyde further to alcohol, right? So this was the reduction of acid chloride. I hope you understand the video. This will be it for today's video. Thank you very much for watching.